Hello students, in this video we are going to solve the problems of exercise 5.6 of the chapter continuity and differentiability of class 12. So here from question number 1 to 5 we have parametric functions, and that means x and y are connected parametrically by the equations. Two equations are given in each question. So without eliminating the parameter, what is the parameter here? In the first one, t is the parameter. Without eliminating the t, we have to find dy by dx. We need to find dy by dx. So let me show you how to find that. So solution. So suppose this is 1 and this is equation number 2. Suppose this is 2. So first each of them let us differentiate each with respect to t. Differentiating 1, differentiating 1 with respect to t. If you differentiate, then you will get dx by dt is equal to twice, sorry, this there should be a square. I think I have written the question wrong. This is here it should be 2. Okay, so then derivative of t square is twice t, so that gives 4t. Okay, so now differentiating equation number 2 with respect to t again, then you will get dy by dt is equal to, if you differentiate here we have to treat a as a constant. Okay, differentiating t, you will get 4at cube. Okay, so now here you see, in order to find, so let me divide the page. So in order to find dy by dx is equal to dx dy by dt is equal to dx by dt. So dy by dt is 4at cube and dx by dt we have got 4at, doesn't it? So here 4at. So then what you will get here, 4 gone, a gone, and t cube by t is t square. So this is, so let me show you how to solve question number 2. Here again, this is suppose equation number 1 and this is 2. So differentiating equation number 1 with respect to theta. Here parameter is theta. So if you differentiate it by theta, then dx by d theta is equal to a derivative of cos theta. Derivative of cos theta is minus sin theta, isn't it? Minus sin theta. So here we will get minus a sin theta. Now let's differentiate the equation number 2. Differentiating 2 with respect to again theta. So then dy by d theta is equal to b derivative of cos theta, again minus sin theta. So here we will get minus b by sin theta. So let me divide the piece here. Therefore dy by dx will be given by dy by dt by dx by dt. So dy by dt, sorry, not t here, theta, not t, theta. So dy by d theta is minus b by sin theta, minus b sin theta, and dx by d theta is a sin theta, minus a sin theta. So here you can see sin theta gone, so minus gone, so we have final result b by a. So this is our answer. So this is question number 3. So x is equal to sin t, this is suppose equation number 1, and y is equal to cos twice t, this is suppose 2. So now differentiate let me write properly. differentiating equation number 1 with respect to t. So then what you will get, dx by dt. If you differentiate this with respect to t, then you will get dx by dt, and derivative of sin t is cos t, so it is cos t. So if you differentiate equation number 2, differentiating equation number 2 with respect to t, then if you differentiate it with respect to t, then you will get dy by dt is equal to derivative of cos theta is minus sin theta, so here you will get minus sin 2t. Again you have to differentiate this twice t. If you differentiate twice t, d dt of twice t, then you must get 2, isn't it? So then the final result is minus sin 2t. Okay, so what we need to find, therefore dy by dx will be equal to dy by dt by dx by dt. We know dy by dt, here we have got minus 2 sin twice t, minus 2 sin 2t by, and dx by dt is cos t, so here it will be cos t. Now we have a trigonometric identity sin twice t. It can be written as 2 sin t cos t, isn't it? So that's going to be equal to minus 2. Again sin twice t will be 2 sin t, so let me clear this, 2 sin t cos t by cos t. Okay, so here this 2 will be cancelled, so here we got minus 4 cos, sorry not cos, sin t. So this is our answer, minus 4 sin. Now question number 4, here x is equal to 4t and y is equal to 4 by t. This is suppose 1 and here it is 2. So let me solve. Differentiate differentiating 1 with respect to t, then if you differentiate it, dx by dt is equal to 4 is constant, derivative of t with respect to t is 1, just 4 into 1 4, and again differentiate 2 with respect to t again, differentiating equation number 2 with respect to t, then it will give dy by dt is equal to 4 is constant, derivative of 1 by t with respect to t is minus 1 by t square, so that is equal to minus 4 by t square. So therefore what we need, dy by dx, therefore dy by dx is equal to dy by dt, dy by dt by dx by dt, dy by dt minus 4 t square and dx by dt 4, so 4 cancel, minus 1 by t square. So that's now let us solve question number 5. So suppose this is equation number 1, this is 2. Now let us differentiate with respect to theta. Differentiating 1 with respect to theta. So dx by d theta is equal to, so derivative of cos theta, it will be minus sin theta, and derivative of cos 2 theta minus sin 2 theta, so here minus minus plus sin 2 theta, then again we need to find the derivative of twice theta. Okay, So that's going to be equal to derivative of 2 theta, that's going to be 2. So we can write 2 sine 2 theta minus sine theta. So now let us differentiate 2. Differentiating 2 with respect to theta. Let us differentiate this equation number 2. Then dy by d theta, that's going to be equal to derivative of sine theta is cos theta, and sine 2 theta is cos 2 theta, then again derivative of 2 theta. Okay, so that's going to be equal to 2 cos 2 theta, sorry, let me keep it, cos theta minus 2 cos 2 theta. So therefore dy by dx, that's going to be equal to dy by d theta by dx by d theta. So let's put the value of dy by d theta. So this is the value of dy by d theta, and this is dx by d theta. So putting those values here, we got cos theta minus 2 cos twice theta by 2 sine twice theta minus sine theta. So this is our result. Now let us solve question number 6. Suppose this is equation number 1, this is 2. Now let us differentiate 1 with respect to theta. Differentiating 1 with respect to theta. So we get dx by d theta is equal to a, and derivative of theta with respect to theta will be 1, and derivative of sine theta is cos theta, so we will get 1 minus cos theta here, and differentiating 2 with respect to theta, then we will get dy by d theta, that's going to be equal to a, derivative of 1 is 0, so then derivative of cos theta is minus sine theta, so that's going to be minus a sine theta. So now we need to find dy by dx. Therefore dy by dx will be equal to dy by d theta by dx by d theta. Now put dy by d theta, that is minus a sine theta minus a sine theta, and this is a 1 minus cos theta, dx by d theta is a into 1 minus cos theta, 1 minus cos theta. Now sine theta, a sine theta, it can be written as twice a sine theta by 2 cos theta by 2. So here we have used trigonometric identities. Okay, and oh sorry, one more thing, this a cancel, so here we have to write only 2 sine theta by 2 cos theta by 2 by 2 sine square theta by 2. So 1 minus cos theta is 2 sine square theta by 2. So here this 2 cancels, and sine theta by 2 cancels sine square theta by 2 here, so we will get cos theta by 2 by sine theta by 2, so that's why minus sine, sorry, cos by sine is cot, so we will get cot theta by 2. So this is our result. Now let me solve question number 7. This is suppose 1, this is 2. Okay, now let us differentiate 1 with respect to t. Okay, here the parameter is t. Differentiating 1 with respect to t. So if you differentiate it, then you get dx by dt that's gonna be equal to, here you see, here we are going to use the quotient rule. Consider the numerator as u and this is as v, denominator as v. We know the derivative of u by v, that's given by v, that is the denominator, derivative of the numerator minus numerator u, derivative of the denominator v dash, okay, by denominator square v square. So we're going to apply this rule. Okay, so here if we apply this rule, then what we will get here, so denominator is root cos twice t and derivative of numerator d by dt of sine cube t minus numerator sine cube t, derivative of the denominator, that is root over cos 2t, okay, by denominator square, that is cos 2t, sorry, root over cos 2t whole square. Okay, now let's apply this rule. Sorry, I have already applied here. Now let us differentiate. So if you differentiate this, then what you will get, let me scroll down the page. Okay, so first here you see this is not only sine t, this is sine cube t. So here we are going to apply consider as x cube, and its derivative is given by 3x square. So replace the x by sine t, then again you have to differentiate, sorry, sine t here. Okay, so that means you have here cos twice t, derivative of sine cube t, 3 sine, sorry, sine square t, not only sine t, sine square t, then again derivative of sine t, now minus sine cube t. So how to differentiate this, root over cos 2t? Now we know that derivative of root x is 1 by 2 root x, isn't it? So if you compare with this one, then you must get 1 by 2 root cos twice t. Then again you should differentiate cos 2t. So let me clean this, cos 2t. Okay, now we know that derivative of cos x is minus sin x. So here you should get, so in this set, in this case you should get, so let me do one more thing, denominator square here cos 2t. So in the next step what we will get, 3 root cos 2t sine square t, and derivative of sine t is cos t, minus sine cube t 1 by 3, sorry, not 3, 2 root cos twice t, then derivative of cos twice t, we know derivative of cos x minus sin x, so here we will get minus sine twice t, then again you have to differentiate twice t. Okay, if you differentiate twice t, then you must get 2, isn't it? So you must get 2, and these 2 and these 2 will be cancelled. Okay, so in the denominator, let me scroll down, is cos twice t. So hope you have understood up to this point. So now what we can do here, so now we will get, okay, so what we can do, okay, now let me multiply both the numerator and denominator by root cos twice t, and if you do so, then you will get here 3 cos 2t into sine square t cos t, sorry, cos t, isn't it? Then here you see this is negative, this is also negative, so it becomes positive. Then here on multiplying the numerator by root cos twice 2t, then this one will be cancelled with this. So what we will get, the remaining terms are sine cube t sine twice t. Then in the denominator we will get, if you multiply root over cos twice t and cos twice t, then you will get cos twice t whole to the power 3/2, isn't it? So now from here you see in the numerator you can take a sine square common, then also you can take, I think what you can take common, maybe cos t. Yes, if you take cos t common, cos t, before taking common, what to do, we have to express this sine twice t in terms of, we can express this as 2 sine t cos t, isn't it? So from here we can take cos t also common, and so then what will happen, then we will get 3 sine square t and cos t. After taking this term common, so 3 cannot be taken as common, okay, 3 cannot be taken as common. After taking these two, we will get within bracket 3 cos twice t. After taking common, we will get 3 cos twice t and 2 sin t, okay, within bracket we will get 2 sin t, not only sin t, because here you see this is cube, so after taking sin square common we will get one more sin t here, so sin t sin square t, isn't it? So plus sin square t, and there should be a 2, okay, we will get this divided by cos 2t by 3/2, to the power 3/2, okay. So this is what we have got. Now let us differentiate equation number 2, this equation with respect to t, okay. Differentiating, this is what we have got, dx by dt. Now let us find dy by dt. Differentiating equation number 2 with respect to t. So this is the 2 I have written here again. So taking this one as u and this one as v, applying this u by v derivative, you will get v derivative of u minus u derivative of v by v square. So if you apply that, what you will get, so at the denominator cos root over cos 2t whole square and root over cos 2t derivative of cos cube t. So we know derivative of x cube is 3x square, so here we will get 3 cos square t. Then again you have to differentiate cos t, again you have to differentiate cos t, okay. So minus the numerator, now numerator is cos cube t, and differentiate the denominator. So if you differentiate this root over cos 2t, we know derivative of root over x is its derivative is 1 by 2 root x, isn't it? So according to that, it should be 1 by 2 root over cos 2t. Again you should differentiate root over cos 2t. So let me write this one here and clean this part. So again you have to differentiate, this is function of function, this is not just root x, this is root over another function. That's why again you have to differentiate the function under the root, that is derivative of cos 2t, okay. Now you see, we know derivative of cos x is minus sin x, isn't it? So in that case, So its derivative, its differentiation should be minus sine 2t. So here I have written minus sine 2t. Again you see this is not only we had here cos 2t, derivative of cos 2t, isn't it? We had derivative of cos 2t. This is not only cos t, this is cos 2t, isn't it? So after obtaining the differentiation, we have got here minus sine 2t. Then again you have to differentiate this term within bracket 2t, derivative of 2t. I hope you have understood this. So I have skipped some steps. So I have done few steps in the first step. Okay. So now let me scroll down. What we will get in the next step. So here you can see derivative of cos t, that's going to be minus sine t. So here we will get minus 3 cos t square t sine t and root over cos 2t. Then here again this is minus, so let me write clearly, this is minus, this is also minus, so it will be plus, then cos cube t by 2 root over cos 2t into sine twice t and derivative of twice t, this is derivative of twice t is 2 only into 2. So here these two cancel. Okay, so let me write the denominator here, that will be cos twice t after squaring. Okay, now from here what you can do, again we can write sine twice t as 2 sine t cos t, isn't it? So if we use this identity, what will happen? Let us use this identity here. So if you use this identity, this sine 2t, this sine 2t, we can replace it by 2 sine t cos t. Okay, this one. So now check the terms before going to taking common. So let me do one thing. Let us multiply both the numerator and denominator, by this term root over cos 2t. Okay, root over cos 2t. So if you do so, then you will get in the next step cos twice t to the power 3 by 2, and here we will get 3 cos square t sin t cos 2t plus cos cube t into 2 sin t cos t. Okay, we will get this. So let me scroll down a bit more. So now what we can do here, that let us check what are the terms can be taken common. From these two, cos square t and cos cube t, we can take cos square t common and then sin t. Okay, we can take sin t common. Okay, let's take common sin t and cos square t. Cos square t. After taking this common, what we will get? We will get 2 cos square t. So here you see, from here we will get cos t after taking cos square t common, and here is also cos t, so it will be cos square t. Okay, then as it is negative terms, so I have written on this side. Okay, here is minus 3 cos twice t. Okay, so hope you have understood this up to this step, and the denominator will be remain same. Okay, so what will be the denominator? Cos twice t whole to the power 3 by 2. So let me write this one properly, cos square. Okay, so now we have got this x dx by dt, and we have got dy by dt. So now we can find dy by dx. Okay, therefore dy by dx will be equal to dy by dt by dx by dt. So now substitute these values, dy by dt. So let me use this value here instead of dy by dt. So let me copy it. Okay, so now, so what we can do here, sorry, just do one, just wait. So okay, so this is our dy, so let me, this is dy by dt. Okay, this is dy by dt. So I have written in red here, and let me write here denominator dx by dt. What was the value of dx by dt? So let me bring the result dx by dt. So this is, sorry, this is dx by dt. Let me copy this. Okay, instead of writing it again, I have copied this one. Okay, so now just okay, so this is the term, so this is dx by dt. Okay, so here what you can do, you can see these two terms cancel. Okay, denominators of the numerator, denominator of the numerator cancel. So what are the remaining terms? So here you can say this is cos square t, and here cos t, so one cos will be cancelled. Similarly here sin square t and sin t, one sin will be cancelled. So that's why our result will be, so what could be the our result? That's going to be equal to, here we will get cos t, and here we will get sin t. Okay, and 2 cos square t minus 3 cos twice t by 3 cos twice t, sorry, the denominator is, yes, plus 2 sin square t. So as you can see, here it is sin and here it is cos. Okay, so I have forgot the square signs, I think. Yes, there should be a square sign. Okay, so let me write it, sin square t. Okay, now you see, as it is sin, so what we're going to do, we're going to convert this cos 2t into sin and this cos 2t into cos, as this is cos. So we know the identities. Here we are going to use this identity, cos 2t is equal to 2 cos square t minus 1, and also we are going to use another identity, 1 minus 2 sin square t. Okay, so we are going to use these two results. Yeah, so if you use these two results, what you are going to have here, then you will get cos t within bracket 2 cos square t minus 3, and within bracket 2 cos square t minus 1, then sin t 3 into 1 minus 2 sin square t, bracket close, then plus 2 sin square t. So if you simplify this, after simplification, what you will get, now multiply here, it will be 6, isn't it? 6 cos square t, and here 2 cos square t. 6 minus 2, that will be 4, and here this is minus 1, that it is minus 3, so it's going to be plus 3. So here we will get the result cos t as 3 plus 4, sorry, not 3 plus, 3 minus, because here you see from this 3 to the 6, 6 cos square t minus 6 cos square t plus 2 cos square t, so it's going to be minus 4 cos square t. Okay, and the denominator, similarly what we will get here, you see 3 1 the 3, 3 to the 6 minus 6 sin square t and plus 2 sin square t, that's going to be minus 4 sin square t. Okay, so here we will get sin t and 3 minus 4 sin square t. So from here what we can do, so just multiply these two terms. If you multiply this one with this and this one with this, then what you will get? Then let me tell you. Okay, so if we multiply this, then we will get these terms. Instead of square, this 2 will be cube, and here we will get not only 3 cos t, and here we will get 3 sin t. Okay, so hope you have understood this. And if you take from the numerator minus sign common, 4 cos cube t minus 3 cos t and 3 sin, so let me scroll down, sin t minus 4 sin cube t. Okay, so again here we are going to use trigonometric identity. 4 sin cube t minus 3 cos t, that is equal to minus 3 t minus 3 cos t, here minus sign. Okay, and this is equal to this denominator, this is equal to sin 3t. Okay, so we will get 3 cos 3t and here sin 3t. I hope you have understood this. So our final result will be, we know cos by sin is cot, so cot here minus sin minus cot 3t. So this is our result. Now let us solve question number 8. Here is the solution. Suppose this is 1 and this is 2. Now let us differentiate 1 with respect to t. Differentiating 1 with respect to t. So if we differentiate, then we will get dx by dt is equal to a, that's going to be minus sin t. If you differentiate cos t, you will get minus sin t, isn't it? So now in order to differentiate log of 10 t by 2, so first assume 10 t by 2 as x, and as t, consider this one as log t. Okay, if you consider this as log t, then derivative with respect to t of log t will be 1 by t, isn't it? So instead of t, what we have here, 10 t by 2, 10 t by 2. As it is not just a single variable, it is a function, so again we have to differentiate this function 10 t by 2. So d by dt of 10 t by 2. Okay, so now a minus sin t by 2 plus 1 by 10 t by 2 Now what will be the differentiation of 10 t by 2? We know derivative of suppose if you do with respect to x, derivative of 10 x is sec square x, isn't it? So instead of x there is t by 2, and we are differentiating with respect to t, so it must be sec square t by 2. Again you have to differentiate t by 2. Okay, again you have to differentiate t by 2, and differentiating t by 2, you will get half. So we can write half sec square t by 2. So hope you have understood this. Now let me simplify this one. So here what we can do here in this case, so let me scroll down. Okay, a minus sine t plus 10t by 2, it can be written as sine by cos, isn't it? Sine by cos is 10, so 1 by 10, so it will be cos by sine, isn't it? So it will be cos t by 2 by sine t by 2 into 1 by 2, sec is nothing but 1 by cos square, sec square is 1 by cos square, t by 2. So after cancelling and simplifying, what we will get? We will get a minus sine t plus 1 by 2 sine t by 2 into cos t by 2. Okay, and we know this identity, 2 sine a cos a is sine twice a. Now instead of a there is t by 2, so sine 2 into t by 2, that gives sine t, isn't it? So this denominator will be equal to sine t. So now let me scroll down. A minus sine t plus 1 by sine t. Okay, so hope you have understood this. So if you take LCM, then you will get a, so 1 minus sine square t by sine t, and we know 1 minus sine square t is cos square t, so a cos square t by sine t. Okay, so this is dx by dt. Okay, this is the value of dx by dt. Now let's find let us differentiate equation number 2. Let us differentiate this. Okay, so differentiating, so equation number 2 is y is equal to a sine t, yes. So here a sine t. So if you differentiating equation number 2 with respect to t, then you will get dy by dt is equal to a derivative of sine is cos, isn't it? Cos t. So we have got this is dx by dt, and we also have got dy by dt. So therefore dy by dx is given by dy by dt by dx by dt. Okay, and if you put the values here, then you will get a cos t by a cos square t by sine t. Okay, so after simplifying, here a will be cancelled, this cos t will cancel this cos square t, so square will be cancelled, and here we will get sine t by cos t, that's going to be 10 t. So this is your answer of question number 8. So hope you have understood this. So what we have got? We have got 10 t. So let me write clearly, this is 10 t. Okay, now let us differentiate, let us solve question number 9. Here first differentiate equation number 1. Differentiating 1 with respect to theta. Here the parameter is theta, so dx by d theta. We know derivative of sec theta is sec theta tan theta, so here we will get sec theta tan theta. Then let us differentiate equation number 2. Okay, differentiating equation number 2 with respect to theta again, then we will get dy by d theta, and we know derivative of tan theta is sec square theta, so here we will get b sec square theta. So therefore now we can find dy by dx, which is given by dy by d theta by dx by d theta. If you substitute the values of dy by d theta and dx by d theta, so dy by d theta is b sec square theta, b sec square theta, and dx by d theta is a sec theta tan theta, a sec theta tan theta. So here, after cancelling and simplifying, we will get here b sec theta by a tan theta. Okay, b sec theta by tan theta. That's gonna be equal to, here you see, we know tan theta is sin theta by cos theta, so here we have sec theta, isn't it? Sec theta, b sec theta, here a sin theta by cos theta, and this cos is nothing but 1 by sec theta, isn't it? So this sec theta cancel, so here we will get only 1 by sin theta, b by a sin theta. So 1 by sin theta is cosec theta, so we can write b by a sin theta, or we can write b cosec theta by a. So anyone, both are true. So now let us solve question number 10 here. So differentiate the first equation with respect to theta again. Okay, differentiating equation number 1 with respect to theta. So if you differentiate it, you will get dx by d theta is equal to, we know derivative of cos theta is minus sin theta, derivative of cos theta is minus sin theta, and derivative of sin theta is cos theta. Okay, so here we will get plus, one more thing, here is one variable, here we are going to use the product rule. It is first function and this is second function, sin theta is second function. So how to find the derivative? First function derivative of the second function, that is d theta of sin theta, then second function sin theta, then derivative of the first function theta. So now you see, if you differentiate sin theta, you will get cos theta, isn't it? So here we will get cos theta, theta cos theta, and here derivative of theta with respect to theta is 1. So here simply we have got sin theta. So we can write like this. So this is our final result, sin theta. Okay, again here plus sin theta minus sin theta gone. So that's why what we have got, a theta cos theta. So now let us differentiate equation number 2 with respect to theta. Differentiating equation number 2 with respect to theta. If you differentiate, now here you see derivative of sin theta is cos theta, isn't it? So dy by d theta is equal to a cos theta minus, so here we are going to use product rule, this theta as a first function, taking theta as a first function, cos theta as a second function. So if you use your product rule, you will get theta derivative of cos theta plus cos theta derivative of theta. So that's going to be equal to minus theta sin theta, and here plus cos theta into 1 means cos theta. So here you see this is negative sign here. So if you multiply this negative sign here, this is going to be plus and this is going to be minus. So what we have got here, theta sine theta and minus cos theta. Okay, sorry, it should be plus. Okay, so here you can see this minus cos theta plus cos theta gone. So our result is a theta sine theta. Okay, so now let's find dy by dx. So finally we need to find dy by dx, isn't it? So therefore dy by dx is going to be equal to dy by d theta over dx by d theta. So if you substitute those values, dy by d theta is this one, a theta sine theta, and dx by d theta is a theta cos theta. So a theta gone, sine theta by cos theta is tan theta. So that's our result. That's how we can solve question. Now let me show you how to solve question number 11. Okay, here you see, if x is equal to this one and y is equal to this, and then we need to show this relation, we need to prove this relation, dy by dx is equal to minus y by x. Okay, so how to do that? So remember one thing, derivative of a to the power x is a to the power x log of a. So this is very important result, you should remember this. Okay, if instead of suppose derivative of a to the power x, instead of a to the power x, if there is a function f of x, function of x, then what to do? A to the power f of x. Okay, a to the power f of x log of a, then again derivative of f of x, that means f dash x. Okay, so here we are going to use this result. So this is 1, this is 2. So let me write the solution separately. Okay, so given x is equal to root over a sine inverse t and y is equal to root over a to the power cos inverse t. Okay, so these two can be written as a to the power half sine inverse t, and this y is equal to a to the power half cos inverse t. Okay, we can write this way. So this is suppose this is equation number 1 and this is 2. Now let us differentiate 1 and 2 with respect to t. Okay, differentiating 1 with respect to t. If you differentiate 1 with respect to t, then you will get dx by dt is equal to if you apply this result, so here f of x is half sine inverse t, isn't it? So according to this result, a to the power f of x, that means half sine inverse t, then log of a, then again derivative of f of x, that means here derivative of half of sine inverse t. Okay, half of sine inverse t. So that's how we have to differentiate. Now if you differentiate, we know derivative of sine inverse, derivative ddx of sine inverse x is equal to 1 by root over 1 minus x square. So if you apply this, so half is constant here, so this half is constant here. So if you apply this result, then what you will get? You must get a to the power half sine inverse t log a and half, let me write the half here. Here you will get 1 by root over 1 minus t square. So this is the result you will get, or you should get. Now let us differentiate equation number 2. Okay, let me clean this part. So differentiating equation number 2. Now f of x is cos inverse t here, cos inverse t. Okay, so differentiating, let me scroll down. Differentiating with respect to, differentiating equation number 2 with respect to t. Here we will get dy by dt, that's going to be equal to a half cos inverse t log of a, then derivative of sorry, I have done a mistake here. This should not be x, here it should be t. Okay, derivative d by dt. Okay, here I have written x, instead of x there should be t. So here half cos inverse t. Okay, so this is gonna be equal to half of, and one more thing, here we will get minus half. Okay, because derivative of cos inverse x, ddx of cos inverse x, that's going to be equal to minus 1 by root over 1 minus x square. Okay, so here a to the power 1 by 2 cos inverse t log a, and it is 1 by root over 1 minus x square. So this minus is written here, this one before half. Okay, so hope you have understood this. Now let us find dy by dx. Therefore dy by dx, that's going to be equal to dy by dt by dx by dt. If you substitute the values of dy by dt and dx by dt, then what you will get? Minus half a 1 by 2 cos inverse t log of a root over 1 minus x square. So half a to the power half sin inverse t log of a 1 by root over 1 minus x square. Okay, so what are the terms here? It will be cancelled here, this one gone, log a gone, then half gone. So here we have got minus a to the power, so we can write this a to the power half, we can write this a to the power half cos inverse t as root over a to the power cos inverse t. Okay, we can write this way, cos inverse a to the power cos inverse t. And similarly we can write a to the power half sin inverse t as root over a to the power sin inverse t. So now as you can see, this is nothing but y, and this is nothing but x. Okay, so again from 1 and 2 we will get minus y by x. This is dy by dx. So here is this is the result that we need to prove. Okay, dy by dx is equal to minus y by x. So what we have done, we have put the value back from equation 1 and 2. Okay, using 1 and 2 you can see 1 and 2, hence proved. So this exercise is completed now. So in the next video we are going to solve the problems of next exercise. So I hope this video is helpful for you. If it is, then share with your friends, and if you are new to my channel, subscribe the channel. Thank you for watching.